NVIDIA has just released a groundbreaking model, Neatron Ultra, that's shaking up the AI landscape. Despite being smaller than DeepSeek R1 in size, Neatron Ultra manages to outperform it in most tasks, showcasing impressive versatility and innovation. What's truly remarkable is that this model, though equipped with a massive 253 billion parameters, can run on a single setup of just 8 H100 GPUs. It's open source, highly efficient, and comes packed with novel features that developers will find incredibly useful. Built on Llama 3.1 with smart architectural tweaks, the foundation of Neatron Ultra is Meta's Llama 3.1 405B Instruct model, which was already known for its robust performance in instruction following and reasoning. But NVIDIA didn't just stop at using this model. They applied a technique called Neural Architecture Search (NAS) to selectively refine and enhance its structure. Through NAS, NVIDIA picked which components of the original Llama model to retain, skip, or fuse. This clever optimization of architecture significantly improves memory usage. The result is a large-scale model that doesn't require massive computational overhead, making it possible to run it on configurations like a single 8x100 node.
NVIDIA accelerated computing starts with DGX, the world's AI supercomputer, the engine behind the large language model breakthrough. I hand-delivered the world's first DGX to OpenAI. Since then, half of the Fortune 100 companies have installed DGX AI supercomputers. DGX has become the essential instrument of AI. The GPU of DGX is 8 H100 modules. H100 has a transformer engine designed to process models like the amazing ChatGPT, which stands for Generative Pre-trained Transformers.
Or even with NVIDIA's B100 or Hopper architectures using BF16 or FP8 precision. Despite the massive parameter count, its memory efficiency keeps it practical for more users. A switchable reasoning mode for flexibility. One of the standout features of Neatron Ultra is its ability to switch between reasoning on and reasoning off modes. This toggling system allows developers to control the depth of the model's cognitive processing based on task complexity. For advanced tasks like detailed mathematics, code generation, or high-level question answering, enabling reasoning on activates a deeper chain of thought process. The model improved its accuracy from 80.40% in reasoning off mode to an impressive 97.00% in reasoning on. Similarly, in the AIME25 benchmark, accuracy jumped from 16.67% to 72.50% when the reasoning mode was enabled. These gains aren't limited to math. In coding tasks, such as those evaluated by Live Code Bench, the model's pass rate surged from 29.03% to 66.31%. On the GPQA benchmark, a general question answering task, Neatron Ultra's performance leaped from 56.60% to 76.01%, all thanks to the deeper reasoning capabilities, outperforming larger models like DeepSeek R1. What makes Neatron Ultra especially compelling is its performance relative to DeepSeek R1, a much larger mixture of experts model with 671 billion parameters. Despite having fewer parameters, Neatron Ultra often edges out DeepSeek in several key benchmarks. In areas like GPQA and instruction following, evaluated by the IFEVOL benchmark, it consistently leads. In code generation, Neatron Ultra is slightly better too. However, math tasks show more balanced results. While Neatron Ultra performs exceptionally well, DeepSeek R1 still narrowly outperforms it on the trickiest problems. For example, on the AIME25 test, Neatron scored 72.5%, while DeepSeek reached 79.8%. Math 500 was a close match, with DeepSeek at 97.3% and Neatron at 97.0%. Even so, considering Neatron Ultra's smaller size and higher efficiency, the trade-offs are minimal and the advantages clear. Fully open source with commercial licensing. Another key highlight of Neatron Ultra is its availability. NVIDIA has released it under the NVIDIA Open Model license, while also adhering to Meta's Llama 3.1 community license. This makes the model both open source and commercially usable.
Good wisdom to go put the whole company behind it. We saw early on, about a decade or so ago, that this way of doing software could change everything. And we changed the company from the bottom all the way to the top and sideways. Every chip that we made was focused on artificial intelligence.
Developers can download the model weights and even access post-training datasets directly from Hugging Face. Whether you're building AI assistants, chatbots, or advanced RAG, retrieval augmented generation tools, NVIDIA encourages developers to conduct their own safety, bias, and alignment tests, emphasizing responsible AI development. A sophisticated post-training pipeline, NVIDIA didn't just rely on architectural tricks to get Neatron Ultra performing this well. They also employed a multi-phase post-training pipeline to refine the model. The first phase involves supervised fine-tuning on specific tasks such as mathematics, coding, conversation, and tool usage. This was followed by reinforcement learning using Group Relative Policy Optimization, GRPO, a method that helps improve the model's instruction-following abilities. Next came knowledge distillation using 65 billion tokens, followed by continued pre-training with another 88 billion tokens. The training data included public datasets like FineWeb, BuzzV 1.2, and DLMA, along with a significant amount of synthetic data. This synthetic data helped the model learn how to appropriately toggle between reasoning modes in real-world scenarios by incorporating machine-generated prompts, extended context window, and developer integration. Another massive plus is Neatron Ultra's maximum sequence length of 128,000 tokens. Some sources even cite 131,072 tokens for precise context. That's a huge leap from the standard 4K or 8K context windows in many earlier models. This extended capacity makes Neatron Ultra especially useful for handling long conversations, analyzing extensive documents, or feeding in large code bases for debugging and summarization. Developers familiar with Hugging Face transformers will find integration easy. NVIDIA recommends using version 4.48.3 of the transformers library. The reasoning mode can be toggled by a simple system prompt such as detailed thinking on or detailed thinking off. For reasoning on, the recommended settings are a temperature of 0.6 and top_P of 0.95, adding creativity and diversity. For reasoning off, greedy decoding, temperature =0 is advised, leading to more deterministic and consistent outputs. NVIDIA has also published instructions for serving the model VLLM, allowing developers to create APIs for their apps. Setup includes specifying the model name, trusting the remote code, and mapping the appropriate device configuration. Real-world hardware requirements. While Neatron Ultra is highly efficient, it's still a heavyweight model and requires solid hardware for inference. NVIDIA tested it on setups with 8H 180GB GPUs using BF16 precision, as well as on configurations with 4 B100 GPUs or even FP8 precision on H100S. Because of the model's vertical compression, compressing and fusing various layers, it uses significantly less memory than you'd expect for a 253B parameter model. This makes it more feasible to run on high-end systems without requiring hyperscaler-level infrastructure. Technical roots and model family. The base model, Llama 3.1405B Instruct, was trained up until 2023. NVIDIA began work on Neatron Ultra in November 2024 and continued refining it through April 2025. During this time, they experimented with skip attention mechanisms, multi-phase training, and dataset enhancements. The Neatron Ultra model is part of a broader Llama Neatron collection. Neatron Ultra represents a major leap in AI model development. With 253 billion parameters, it delivers top-tier performance while remaining memory efficient and cost-effective. It often outperforms models like DeepSeek R1 despite having fewer parameters, and introduces groundbreaking features like switchable reasoning modes and ultra-long context windows. Fully open source and commercially usable, it's available now on Hugging Face for anyone to explore and integrate. Whether you're developing AI agents, chatbots, RAG pipelines, or multilingual tools, Neatron Ultra is a powerful new option that balances performance, scalability, and transparency like few others in the current landscape.
Real-world use cases and impact Neatron Ultra isn't just a research marvel, it's a game changer for real-world applications. Developers can build smarter AI assistants capable of deep reasoning, faster customer support chatbots, and powerful code generators, all without relying on prohibitively large infrastructure. The model's support for extended contexts means it can be used in legal document analysis, scientific research, and even real-time financial forecasting. With its commercial-friendly license, companies of all sizes can deploy it safely. Whether you're in tech, education, healthcare, or finance, Neatron Ultra empowers innovation by making advanced AI more accessible, scalable, and adaptable to diverse business needs. Developer-friendly and future-proof NVIDIA has designed Neatron Ultra with developers in mind, providing extensive documentation, dataset access, and model weights on Hugging Face. Integration is seamless with the Transformers library, and the clear toggling between reasoning modes puts users in full control. Its impressive efficiency also makes it more future-proof. especially as AI hardware becomes increasingly optimized for FP8 and BF16 workloads. This model is a perfect fit for those building with LLMs today while planning for tomorrow's AI ecosystem. Whether you're an indie developer or part of a large team, Neatron Ultra offers both power and practicality in one open source package. That wraps up of the NVIDIA's Neatron Ultra, one of the most exciting AI models of 2025. If you're as impressed as we are, go check it out on Hugging Face and start experimenting today. Don't forget to like, share, and subscribe for more AI breakdowns like this one. And hey, if you're into AI tools, prompt engineering, or marketing automation, make sure to visit Judith Marketing for more information about AI and marketing. Thanks for watching, and we'll catch you in the next one.